My name, as you know, is Antonio Jesus Torres Gil. I'm a secondary teacher in a high school in Spain. I teach physics and chemistry in Santo Tomás de Villanueva School in Granada, and I'm going to share with you some successful experiences using the iPad as a chemistry learning tool. In last years, crisis on science education has led to an increase in the use and research of ICTs applied in science teaching. In fact, most experts agree with the need to incorporate the science and technology in science teaching through ICT resources. Recent research on ICT resources in education shows us that they improve learning procedures, development of intellectual skills, and teacher training. Most of teaching approaches have increased its efficiency with the application of ICT resources. But the recent emergence of mobile technologies in the classroom, iPads and tablets, allows the use of educational tools everywhere and every time, and raise on students' motivation. Furthermore, when ICT resources are applied together with some methodologies as project-based learning and collaborative learning, most of teachers agree with the fact that they can get a most effective learning. We will begin with a work environment description. In our school, we use iPads in classrooms, and 2013 as first and second levels of upgrade school, 16-18 years students. We use an electronic version of textbooks, and all our classroom feature wireless internet access. I will describe two activities using iPad developed with a 35 students group from first course of upgrade school in the subject physics and chemistry. First of them has been made using an app on molecular 3D visualization, and the second activity we have used 3 online applications about kinetic theory, 2 of them that you can find in the teaching resources section in the web of Chemistry Accelerator Network. Finally, I will show the results of an evaluation about learning effectiveness obtained with these 2 online applications. As I told before, first application, is an app of molecular 3D visualization from the Apple Store. The app is called 3D Molecules Edit and Read, and with it you can create organic and inorganic molecules and visualize its 3D structure.
Another way is to copy the drive.
Yes, it's copy. I don't know. Wait. One moment. I'm going to put with sound, because if I don't put the sound, it doesn't run.
Okay.
Okay. Well, the student work with this is called 3D molecules edit and read. With it you can create organic and inorganic molecules and visualize its 3D structure. This activity was carried out at the end of the didactic unit about organic chemistry and carbon compounds. Small groups with 3-4 students elaborate models in 3D organic molecules based on their previous knowledge, and their designs were uploaded in a shared folder Google Drive during 2 sessions of an hour. In the last session, students shared their models discussed the weak points, and made changes in the data collected on the folder. It's also of interest to note that knowledge of organic nomenclature is not always accompanied by a suitable knowledge of a molecular structure. This resource use has helped to correct comprehension mistakes about some functional groups like carboxyl or carbonyl, and even helped to effectiveness in the reading of isomers structure. We obtained very positive results. We collect 3D models from 130 millirecords, 39 hydrocarbons, 71 oxygen-containing hydrocarbons, and 20 nitrogenous hydrocarbons. 70% of the pupils who participated had positive marks in this activity. An evaluation form was developed and filled by the students, and this activity was positively assessed by 80% of the students, and the experience was qualified as motivating and allowed them to clarify concepts and reduce uncertainties. Now, the 3 applications that the students worked were two online simulators elaborating in Flash about kinetic theory and the early gas laws, Boyle's law, Charles' law, and Gaius' law. The didactic approach applied during the didactic unit was a traditional approach, except in the contents about kinetic theory and early gas laws. The first application was used instead of textbooks during the explanation of the contents about kinetic theory and early gas laws. It is the application of, it's not possible. No, it doesn't run the link. Don't mind, in this application you can see how the molecules have a more kinetic energy when the temperatures are up. And how I said, how I told you, it was applied in 2 steps: reading and visualization, and a group discussion to share the most relevant aspects. The second application was used during a virtual laboratory session with small groups of 3-4 students. The second was used to see the early gas laws. No,
you can try to
Yes.
copy, but I'm not too sure.
Okay, I will try. I don't know what happened. Don't mind. Perhaps if they. But I don't know if yes. Okay, thank you. The link.
No, remove.
No, lei rimosso.
No.
Just moved out. Collegamento copy.
Copy.
No.
Copia in a second, yes?
No,
Okay. Okay.
ormai l'ha cancellato.
Ha perso. Yeah.
Thank you. Collegamento.
Mi per adesso
Deve fare annulla. Annulla 2 volte.
I don't know. Don't mind. It's only to see that I can suppress this part. Yes, so. nucleic acid laws. And the students could change volume, pressure, temperature, and see how does it run. Well, it was applied, the third application was used during a virtual laboratory session with small groups of 3-4 students, and to evaluate the effectiveness of this methodology based on ICT applications, we set an exam and compared the results of both methodologies, traditional and ICT. The results are, you can see in this door entrance table. We marked a control question, traditional approach, and a similar ICT question to compare them. We divide question results in A, good mate, in A, a question good mate, B, acceptable, and C, wrong. Number on in this ICT question we can see in the top, and in the left the control question. We can see that number of answers qualified with A and B for the ICT question here is higher, 80%, than the control question. And students with A in ICT question and A in control question are about 22% full agreement, while the pupils with AC and CA low agreement between the two questions taken together count for 14%. Then we can tell you the next conclusions. The introduction of iPad in science teaching allows to work in small groups, facilitates the exchange of data and discussion environment. New technologies applied in the science classroom can increase students' motivation. Our students obtain higher qualifications with the methodological approach based on ICT than traditional teaching approach. An improvement of meaningful learning is helped by a non-traditional teaching approaches and ICT resources applied together. Thank you for your attention. You have